Hello and welcome to a new tutorial. You don't see anything yet. We are in an empty landscape that I created. Today we want to have a look at some things in PCG from scratch in the Procedural Content Generation framework. Epic Games introduced this framework in 2024 and since then it has received a lot of love and many new features. Today, we mainly want to explore how to work with meshes, how to work with actors, and how to access data from actors or meshes that are already in the level but not actually present in the PCG graph. We will see how to work with data, retrieve it, and establish communication between the PCG graph and other actors in our world and level. You can create a lot of great things with this, like what you see here, for example. This is what we will have created by the end of the tutorial, but let's take it step by step. The primary focus today will be these elements at the top. First, we will look at get actor data, a node that allows us to retrieve data from an actor, whether it's inside a PCG graph or, which is very powerful, from any other actor in our world. Then we have the mesh sampler, which we'll also be using. The nodes we will primarily be working with today include distance nodes, specifically the spatial distance node. Additionally, we will focus on these two nodes below, which you will find inside the execute blueprint node. This node allows you to execute various pre-made blueprints, but you can also modify or create your own. In this specific case, we will be working with the height density and scale by density node, which will allow us to create some really interesting effects. We'll see in a minute. The secondary topics we will be covering include noise, specifically density noise, since we are working a lot with density today. We will also use a density filter in general. Noise generation and filtering are important, if not the most important topics in PCG, and you will get a brief overview of these as well. Before we get started, let's go over the necessary plugins. You should activate these 4 plugins you see here. Starting with the PCG framework itself, ideally you should also enable the other 3 plugins, though they aren't strictly necessary for this tutorial, but maybe you want to experiment with other stuff later on. By the way, this is more of an intermediate or beginner to intermediate tutorial. That means if you have no prior experience with PCG, you might need to catch up on some basics first. Without further ado, let's jump right in. Once we have all the plugins installed and activated, we can create a new PCG graph. We will do that now and name it falloff. The first thing we will do is a small exercise, just to get a feel for how we can reference data from an actor and work with it. As you can see, we have a nice empty landscape. That's perfect because we are going to start by retrieving landscape data. We don't need to adjust anything in the details panel. We can leave it at the default settings. Next, we will add a surface sampler, set it to 20 points per square meter, and adjust the extents to 10. One important thing. There's an option called apply density to points. We don't want that enabled, so we'll uncheck it. You will see why in a moment. Now, what we have at this point doesn't look like much. I can drag the PCG graph into our level, but we still won't see anything. However, when we enable the debug for the surface sampler by pressing the D key, we will suddenly see a lot of points, all of them the same color, white. As you probably know, In PCG terms, density is a value between 0 and 1, assigned to each point. This density is visually represented using black, white, and all shades of gray in between. Since we will be working with density a lot in this tutorial, I wanted to showcase the upcoming change more clearly, and that's why we don't want to set it in the surface sampler right away. Now, what we actually want to do is use getActorData. We want to retrieve data from an object that exists in the world and use it in our PCG graph. If we take a closer look at the details panel, we will see an actor filter. The great thing about this is that we are not limited to just self, which means in this specific case the PCG graph itself, but we can also access all world actors. When we enable this option, we get an actor selection setting where we can filter actors by tag or by class. This is very powerful. If we select by tag, we can enter a tag directly. Let's call it PCG test. One crucial, very important thing to remember, just like with all tags in Unreal Engine, is that the spelling and the capitalization must be exact. Let's copy this tag, switch over to our level. I will move things around a bit, and now let's drag a cube into our level. We will scale it up a bit so it's easier to see. And this cube does not exist in our PCG graph. It only exists in the world outliner in our level. Now, when we select the cube and check its details panel, we will see an option to assign tags. Let's add the exact same tag we copied earlier. The actor selection tag must match exactly. Very important. Once that's done, we are already receiving data, but we are not using it yet. What we want to do now is bring in the distance node, which we looked at earlier. Let's drag it into the graph. We now have two options, source and target. Source represents the points that we want to modify based on their distance from another object. In this case, our surface sampler with all the points. Target is the object we are measuring the distance to. In this case, our cube. We can simply connect the target input and it will automatically be converted. Thank you, Unreal Engine. However, if we disable the debug view for the surface sampler and enable it for the distance node, we still don't see anything. Why?
Compute says no.
The reason is that we haven't set anything in the distance node yet. The first thing we want to do is modify density. You notice in the background that everything suddenly turned black. That means something is happening. A density value is definitely being assigned. However, it doesn't seem to be linked to distance yet. The cube isn't correctly influencing the distance values. To fix this, we need to adjust maximum distance. If we gradually decrease it, we can already see a gradient forming in the distance. Let's set this to 1500 so that we get a nice smooth gradient in the center. If we move the cube now, the gradient follows it precisely. That means we have successfully established a dynamic connection between the PCG graph and an actor in our level. So what can we do with this? First, let's change the source shape and target shape to box. This slightly alters how the effect is applied and helps us better match the cube's shape. Next, we want to apply the scale by density node. If we try searching it, it doesn't show up immediately. That's because we first need to add the execute blueprint node. In the template field, type, scale by density, and the node will transform into exactly what we need. Now, let's configure it. So the minimum scale I would set to 0. That's fine. The maximum scale, let's leave it at 1 for now, just for demonstration purposes. We will disable the distance nodes debug view and enable debug for scale by density instead. What do we see? Okay, all points close to the cube, represented as black, shrink to 0 size. As the distance increases, the points gradually get larger. This gives us a powerful way to manipulate elements based on distance. Now, let's refine this further. The next step is to add an attribute noise node. Now we set the attribute noise to input source density, exactly the data we have created earlier. That's important to always hand over the right type of data when we are working with the attribute noise node. What we are doing here, we add values between 0 and 1 to the existing density. The default setting already works well, so we can leave it as it is. What happens now? We can see in the middle that we now have smaller, darker points appearing. The previously smooth gradient is now slightly disrupted here and there. We have introduced a subtle noise pattern into this distribution. And why we are doing this? The scale by density node shrinks points based on the distance. But I also want fewer points near the object. Not just smaller ones, but sparser ones as well. So why we add instead of set? If we used the set option here, the noise would be completely randomized, overriding the existing pattern. By using add, we modify the existing density without completely replacing it, maintaining the structure while introducing a variation here. Now, we apply a density filter to remove specific values. I want to filter out nearly all points with density between 0.99 and 1. As a result, we see small patches where points have been removed. By tweaking the values, we observe how the density distribution dynamically changes. Particularly in the center, the pattern becomes less uniform, more organic, and that's exactly what we aimed for. So we are now not just scaling points, we are sculpting the density itself. So, as a conclusion, this technique allows us to dynamically react to the environment. What I wanted to show you here is that the getActorData and distance node enable us to use world data directly in the PCG graph. A practical example could be if you imagine that you want to create a road. And with this method, you can ensure that grass only starts growing after a certain distance from the road, or that trees, for example, become smaller and less dense the closer they are to the road. This may not be the most spectacular example, I agree, but the principle behind it is extremely powerful for procedural level design. And what we have done here is just the beginning. We will now take it into a more complex example. We are moving on to the main part. We have understood how the density node works. We have seen how to use getActorData to apply it in a procedural setup. Now, let's revisit the example we saw at the beginning, the one with the tree. We are going to recreate it using what we just learned, but this time we will also introduce the height node that you saw earlier. And importantly, we won't be using the get actor data this time. Ha! What a plot twist. So first, we use the get landscape data node. We don't change any of its details. We use the surface sampler again and leave it at 0.1. However, we set the extents to 50, 50, and 50. Then we are using a random choice. We set the fixed number to 2 and we don't allow discarded entries. Next, we add transform points node. This is best practice. I always do this before adding a static mesh spawner. Why? Because it allows for randomization and adjustments before spawning objects. For example, you can tweak scale, rotation, or other properties. In this case, since our example is a tree, this step is particularly useful. Imagine you have a landscape with hills or mountains. Without adjustments, the tree might spawn at a 45-degree angle, sticking out awkwardly. To fix this, we just enable absolute rotation. For your own projects, depending on your needs, you might choose different settings here, of course, but for this example, we will go with this. Now we spawn the static mesh. We use tree_1 as our mesh. Let's resize the window so we have a 50-50 split and we can see everything more clearly. That should be good. No need to debug anything because we already have a static mesh spawner. And now we have a beautiful field that we can see here with 2 tree sticks. But there's a problem. While the mesh itself looks great, the transition here to the ground isn't very smooth. This is exactly what we want to fix using the power of PCG. So, what's the plan? Logically, we will use the distance node again. It's the same approach we have used before. I will go through this part quickly since we have already covered it. What do we need as a source for the distance node? We need data from the surface sampler, but not the same one. We want slightly different data. I will plug this into the source. As mentioned, this is identical to what we did earlier. For the surface sampler, I will set it to 200 points and make them slightly smaller. Again, we're not applying density to points, not important now, but again, always keep your workflow as clean as possible. Now, we had the distance node. Previously, in our example, we got the target using getActorData. That means we pulled in a cube from the world outliner. But now, we are already spawning meshes within the PCG graph. This means we can directly take the target from the static mesh spawner. This is super useful and makes things much easier. Let's enable the debug. As expected, everything turns white. We have a lot of points and currently none have any density. Now we set the density just like in our previous example. Everything gets colored in again, but we need to reduce the density here. As soon as we do that, look at the upper edge of the screen. It fades to white again, and yep, it's forming a gradient. I would say let's set it to 1500 again for now. Maybe that's a bit much. Let's try 1000 instead. And now we have a smaller gradient, which looks nice. This fits very well in the corner. I'm happy with this. So what we are doing here is we could change this box bounds, but as you can see, there is not much of a difference. So let's leave it for now. We are happy with that. Next, we will go to the execute blueprint. The scale by density node can be found within it, and we activate it, and then we choose this value. We'll go with 0.5, which is the lowest value, and we will move it into negative values here. Why? I will show you. We actually want to make things very, very small. Here's what it looks like. Yes, we still have some white areas in the back, but don't worry, we will remove those shortly. First, let's apply a density filter. The density filter in this case will filter out everything between 0.1 and 1. When we apply it, we don't see much improvement yet. Now, we have this circle here, a half circle there, and something else over here. If I want this kind of pattern, it can be really cool and interesting. It could be used for an impact, for example. Could be useful indeed. However, we want to create exactly what we see in this area here, which is around the tree trunk. All the other points should be removed. We have already done a good job here. We intentionally made these points a bit smaller than the others, but not by much. I set these values this way because we just want a small size difference, but with a slightly different distribution, which is why these values look a bit odd. Now, we want to thin out a bit more. So I will add a noise node. We will choose density for the input again. That's always very important. We will set it to add this time. Not 0 and 1, but instead I would say 0 and 0.6. Let's take a look at how it looks now. It looks beautiful with a nice mix. That's exactly what we want. Now, let's apply a density filter again. I would set it to 0.1 and 1 for more flexibility, for a bigger range, but also inverted. We can see that we now have a beautiful few points which are distributed very organically around here. This is exactly what we need for what we are about to do next. Of course, we can keep playing with this. If we want to add a little more, we can, but I think 0.1 and 1 is the right value here. First, it gives us a good radius around the objects, and the inside is nicely thinned out. Now, let's use a projection node. I mentioned in the beginning that we set the absolute rotation in the transform node, and we also want to place these trees, for obvious reasons, on the landscape that has been sculptured. So we need to project all the points onto the landscape. So we take the projection node and connect it to the projection target here. And we see it works perfectly. So we already have our points here. We are pretty happy with how things turned out. Now we add a transform node following by a static mesh spawner. We will talk about that in a minute. So let's summarize our first part here. In short, the first part is complete. We generated points around our meshes. We can control the radius around the objects. We applied scale by density. We thinned out our points, which is what we have done so far. We have experimented a bit, changing the values of all our filters and the noise node. This is part of the magic of PCGs actually. You can tweak the values yourself and figure out how to filter and apply things to fit your creative needs and your project specifically. Now, let's take a look at the second part. I will clean up a bit here so we have a good overview. So in the second part, we want to do something with the mesh itself. How do we do this? We start by adding a mesh sampler for the static mesh spawner. When we select it, there is an error saying that we can't plug things in. However, we have the option extract mesh from input at the top. Now we can use it and the error goes away, which is great. Let's check the settings and see what we can adjust. First, I would add a bounce modifier. From my experience, especially when working with meshes, it's often necessary to adjust the bounce a bit to get a clean result. In general, when we work with a mesh sampler or even with actor data, it's always best practice, at least for me, to add a bounce modifier. In this specific case, we don't need to change anything. So let's debug it and we see nothing yet. This happens because the mesh sampler doesn't actually do anything yet. Right now, these are just data, but we can't visualize them yet. So we take the copy points node and use the points we extracted as the source. The target here is the mesh itself. Let's get a closer view here and try to understand this better. I will show you with the debugger. Copying points to the mesh. Okay, so they are aligned correctly according to the normals of this mesh. This is really powerful and looks great. So what we have done here is that the mesh sampler is initially just pulling the mesh itself. You can think of it as looking at the mesh in an empty space, not necessarily in your level. That's what this tool does. It looks at the mesh and will project these points onto it, but it doesn't know where the points should actually go in your level. That's where the copy points node comes in. The target here is the exact location of the static mesh that was spawned. As you can see, these points are now applied correctly and it works beautifully. Next, we want to use the height to density node. We find it in the execute blueprint node again, and we will stop debugging the points here for now and make some adjustments here. So there is a gradient offset, which we will look at in a moment. But first, let's check the gradient scale. Let's set the gradient scale to 250, and for the density mode, we will select set. When we debug this now, we can see something interesting. There are dark points at the bottom and bright points at the top. This means something's happening with the height, which is quite exciting. If we change the gradient offset now, we will see how it affects the points. For example, if we set it to 20, we notice that the points have grown a bit. Setting it to 50 will raise the points even higher. We want 20. It works well for the lower part here, where we have the darker points. I like this. What we want to do again is use the scale by density node. You have probably noticed that I'm a big fan of it. What we are doing here is setting the scale to 0.5 and -2 this time. When we debug this, we can see that the points at the top are really large. The ones at the bottom are small. And something happens in the middle here. Since I know exactly where I want to cut off, this is a good value for me. We could technically generate this in a different way, but I want to keep the node here at this place, at this point, and I think the values work well. Again, for your own projects and purposes, you should always experiment with values. Of course, what we need to do next is apply a density filter, because usually we want to get rid of the points where the density increases. Again, let's take a look at what happens here. Now only the points at the top remain now. but we know that our density filter has a useful feature, the inward filter checkbox. And that's perfect. Now we have filtered out a good portion of the points that we want to filter out. It's not everything, yeah, like before, but most of it. As I said, you could actually do this differently. For example, if you apply the density filter here, and let's say we filter out a bit more like this, we set the value to 0 here, let's say, and this one to 1 and debug it, then we will see that we have essentially scaled in the wrong direction, but this could work too, right? But what we also notice here is that the size differences aren't that big, that large at this point. So, of course, we could influence this further by entering negative values here, but for my taste, it's actually simpler to do it with the values here and just put 0.5 and -2 again. And then work with the density filter set to 0.5 as well. We will filter out the rest, don't worry. We are going to create another noise node. We will choose density here again, and that will remove the arrow. The noise will be set to add in this case, and we will add a value from 0 to 1. Then we will add another density filter. And let's first take a look at the density filter and see what happens. Right now, not much has been filtered out actually, but if we go down here, you will see that nearly everything is still there, but there are some gray points at the bottom. If we enable invert filter and set it to 0.3, now we can see that we still have some small gray points, but many of them are black. I figured out that this value works fairly well for me. So at this point, we still have some points, not too many, and that feels pretty good. We are pretty much done here at this point. We will add another transform node and a static mesh spawner, and now we will take a final look at all the points that we have created. We have some on the ground and some that reach up to a certain height on the tree. I'm just going to work a bit with time lapse here and add a few things like, some mushrooms, for example, just so you can see what we are actually generating. The mushrooms are very organically and beautifully growing here. These mushrooms will only grow to a certain height for obvious reasons, which we can control. This is very powerful when we are talking about PCGs. And you can see that, for example, this small mushroom here at the top is actually a bit smaller than the one at the bottom. A quick wrap up. We have basically started by getting our landscape data, applied a surface sampler to create points afterwards. We have spawned trees in our specific case here. However, we also generated points again here to later use in the distance node. What we have done here is basically the same thing we saw earlier in our little exercise in the beginning. We have used the distance from the object we spawned to the large field of points and created a gradient. This allows us to scale the smaller points, applied various filters to thin them out, and projected them again to ensure that if we have some hills on our landscape, for example, the points will always lie nicely on the surface. What we did here is a bit different from the example before. Here we actually used points to mesh, as I will call it for now. We sampled the mesh. We didn't necessarily need a bounce modifier here, though I think it's the best practice, and then copied the points to work with them. What we did here is also new. We used the height to scale different points with these exact values, we filtered the points further, thinned them out, and then spawned a static mesh here. I will make some final adjustments with the art of video editing and add a few more static meshes here, and now you will see the final result, which feels way more organic than the blank tree trunk before. So PCG is a fantastic tool that allows for creative experiments. Hopefully this tutorial has shown you how to communicate with static meshes and other actors within PCG, so you can now apply these principles to your own awesome projects. Thanks for watching and see you next time.